Yesterday, you were introduced to the idea that there's different types of compounds. Of course, a compound being different elements bonded together. The type that we introduced you to was ionics. And you know that if something's ionic, it means that the two items from that table that are being joined together, one is metal, the other non-metal. Or one's a cation and the other's an anion, which is a different way of saying the exact same thing. Or one we're going to look at a lot more today, one of them is polyatomic. If something from your polyatomic list is in that compound, automatically ionic. And what we've been talking about applies. Now, I know there was an opening slide. I meant to show it to y'all, but we're not looking at it yet. So you people at home, I'll show it to you in a moment. I didn't finish everything I wanted to finish in lecture 1 of this topic. So let's dive right back in to where we left off. Real quick, though, remember that when an ionic compound comes together, what's really happening is there's valence dots that move around to make the octet happy everywhere. But we have a shortcut where we can find the oxidation states of the metal and non-metal and crisscross them into subscripts to not have to draw the dots. But hey, what was the little twist on the rules we learned at the end before you crisscross those values? If you can reduce them, reduce them. So with that said, let's keep going. Write down this next example. Start with symbols again. The symbol for rubidium is, anybody? Yeah, we got the meats. They got the meats. Hypochlorite. Who wants the gold star? What is the formula for hypochlorite? It's just ClO. Now, some people want to say the charge. That's a different question. Hypochlorite is on your polyatomic list, and those of y'all that memorized them like you were supposed to, you knew that as soon as you saw that word, right? Hypochlorite is listed as ClO. Now, I know this is going to be ionic because there's a polyatomic as a part of it, so automatically ionic, all right? So let's find the charges. Let's go over to cluster 5, C2. Hey, 5-2, what is the charge of this rubidium? Quiet. 1, right? Rubidium is in group 1, so it's +1. Anybody in the room, what is the charge of hypochlorite? -1, because the polyatomic list says so. There's just a negative symbol floating with no number, and lack of a number is a 1. So what's going to ultimately happen with our formula? Yeah, you just need to shove them together because the ones don't show up. So the final answer for rubidium hypochlorite is actually pretty simple. All right, so this is our first example where a polyatomic ion has showed up, but none of the steps change, right? Fine, let him be polyatomic. Find his charge and crisscross. Let's do another one. Write down our next example of aluminum sulfate. The symbol for aluminum is Al. Let's go talk to someone. Let's go over to cluster 1, seat 6. Hey, 1-6. What is the formula for sulfate? SO4. Does everybody see where I'm getting this data? All right. Here come the other fun questions. Aluminum has a charge of +3 because he's in group 13. Now let's go over to cluster 3, seat 6, aspen. What is the oxidation state of sulfate? Find him. He's on your polyatomic list. You just have to find him. Look at the charge. Negative what? -2. Pass the bird. He's -2. Hey, based on the rules we've learned, can those oxidation states cross as is? Definitely, right? Because it's a 3-to-2. 3-to-2 is a ratio that cannot be reduced to any simpler whole numbers. So we're going to cross the 2 there and the 3 there. Now, this looks a little muddier, doesn't it? Unlike any example that we've done, which leads us to our next twist, our next fun rule. Look here and write it down. Copy down the next rule. People at home, always feel free to pause the video if I move too quick for this part. It says if a polyatomic ion is crossed a value greater than 1, add parentheses. It's a very simple rule that will solve the problem that we have here. Now look, watch me think through the words, all right? If a number bigger than 1, you see how that's a number bigger than 1, is crossed to a polyatomic ion, anything on this sheet, then you put parentheses around the ion. That's the entire rule. But hey, look here. I'm going to draw it, but watch. Why does aluminum not need parentheses? That number's bigger than 1. It's not a polyatomic ion. One of the problems with when I introduce parentheses is one of you becomes the parenthesis queen, and you start putting them around everything. All right? Follow the rule. Aluminum does not need parentheses because he is not a polyatomic ion. Sulfate does need parentheses because a number bigger than 1 was crossed to him, and he is a polyatomic ion. Al2SO43 is the only way to write it. And why? What does this mean? Well, it means that if we were doing dots to make the octet happy, you would draw 2 aluminums and 3 SO4s is the way that it works. Easy? Let's do another one. Barium cyanide. Barium has a symbol of Ba. Let's go over to cluster 3, seat 5. Hey, 3-5, what is the symbol of cyanide? Cn. Reading straight off his sheet. I know it's ionic because cyanide is polyatomic. So all of the ionic stuff we've done yesterday and today apply. So let's find charges. Hey, look, barium is in group 2, so he's +2. Let's go over to cluster 4, seat 6, aspen. What is cyanide's charge? -1. Because the sheet says so. Hey, you okay? Can I cross these purple numbers as is? Yes, they can't be reduced. 2 to 1 cannot be reduced to any simpler whole numbers. So cross them. That goes there, and that goes there. So what's the answer? How do I write it? Do you see how some of y'all missed the parentheses? Some of you didn't think you needed parentheses. The reason the parentheses are less obvious here is that there wasn't already a subscript there, right? In the previous example, sulfate was SO4. So when you tried to cross a number to them, you're like, but there's already a number there. But that's not what the rule says. The rule doesn't say, guys, the rule doesn't say add parentheses if there's already a number there. It says add parentheses if a number bigger than 1 is crossed to something on this sheet. So be clear on that. This is the only correct answer because I don't want just 2 nitrogens, which is what it would read if there were no parentheses. I need 2 cyanides to do the octet. You do both of those. You got 2 minutes. That's a minute per item. Get them done. The red ones.
Why are you looking for? That's not how it works. Phosphate. Oh. So I think I got it right.
No. Remember, you got that one right in August. That was your one for the year.
Which one was up?
I remember that.
So my birthday's in August. No, but chill. So I think we need to go through.
Don't you went up. Are you okay?
No, it hurts.
Go run water. Go, I have soap and water back there. Go clean it. That'll hurt more. Quit touching people. All right, let's see if we can get some help on just the first one. Strontium phosphate. Let's head over to cluster 4, seat 1. Hey, 4-1, do you want to just give me the formula you came up with? Do y'all agree or disagree? It's perfect. Why is it perfect? Well, she saw that strontium was +2. On the polyatomic, phosphate was -3. They couldn't be simplified. So the 2 went there and made parentheses because that is bigger than 1 and that is polyatomic. The 3 went there, and just, it was normal, wasn't polyatomic, so no parentheses. And that is the only correct way to write strontium phosphate. I'll do the next one. Calcium dichromate. Calcium is Ca. Oh my God. I probably have to retire. I don't think I can. For those of y'all at home, I tried to make it in the trash can. It went around the rim of the trash can, bounced up, and landed on the tray on the other whiteboard. So it was epic. You were a part of it. You can rewind and watch it again if you want to. Anyway, no, it was green. You can't ruin it by, no, it was, dude, it disappeared. God, I'm good. All right. Calcium is Ca. Dichromate, as you here, well, give me another try.
Yo, if he does this, I'll actually give him $5.
It's gonna land in Alejandro's mouth. Watch this. Oh, it tried to rip. Dichromate is Cr2O7. All right, here. No. Come on. The bell's gonna ring. I'm not gonna finish my video. Okay. Hey, I know it's ionic because dichromate's polyatomic. Y'all, that part is more important than you realize right now, because if it wasn't ionic, what we would do next would be different. So everything's ionic so far. Anyway, calcium from group 2 is +2. Dichromate from your list is -2. Do you agree? Those numbers can be reduced, right? So don't add parentheses around him. No, that would be wrong. Because 2 over 2 is the same as 1 over 1. So when you cross them, nothing happens. So again, don't put parentheses where they don't belong, especially like sometimes y'all are like, oh, let's just put parentheses around all the polyatomics. No, it's got to be a number bigger than 1 being crossed. Questions? What about the oxygen? Well, that is dichromate. Cr2O7 is dichromate, which is exactly what the words say. All right. Now, for those of y'all at home, when they first got in, they copied down this, so you need to pause it and copy that down. Copy down the opening notes. All right, look here. Shh. We already learned last unit that the transition metals use Roman numerals for charges. The reason that they do that is because the transition metals in the middle of the table, groups 3 through 12, have multiple charges. For example, if I said iron oxide, I said I want you to write the formula for iron oxide, you would have to look at me and go, I can't, because you couldn't. I didn't give you enough information. If I say iron oxide, you would need to know the charge of iron to do it. And iron can be iron 1, iron 2, iron 3, depends on which iron, in order for you to do this number stuff. Therefore, transition metals have Roman numerals. As you already know, they're always positive, and they have to be given to you, right? I can't just name a transition metal. So we're going to practice that in a moment. Now, to make your life awful, the last bullet here on the screen mentions that zinc, cadmium, and silver don't use Roman numerals. Those are transition metals. Well, the reason that there's 3 that don't is because there's 3 that only have 1 charge. Remember, the whole reason that we're about to start looking at some Roman numeral problems is because those central elements have multiple charges. But if there's some that don't, then they wouldn't need Roman numerals. So it's these dudes right here. The screen said it, but zinc, cadmium, and silver have a constant charge. Therefore, they don't get Roman numerals. All right, so zinc is always +2, the same way that beryllium is always +2. So why would he need a Roman numeral? He wouldn't. So with that said, let's rock and let's rock and roll some more problems. Write this down. Iron 3 oxide is how you would say that. Y'all, the steps are the exact same. Actually, these are easier. Look here for a minute. Don't try to solve it, please. We're working together. Students a lot of times get to the point in this unit where they're like, oh, I hate Roman numerals. The Roman numeral problems are hard. And that is the wrong perspective. The Roman numeral problems are the easiest ones. They're the only ones that give you the charge in the question. Like so far, there's a metal and a non-metal in ionics, right? You've had to go and find the charge. If it's from the periodic table, you have to go look it up. If it's on the polyatomic list, you got to go look it up. But if it's a Roman numeral, you don't have to go look it up. It flat out says, hey, here's my charge. And then you can just use it. Let me show you what I mean. The symbol for iron is Fe. The symbol for oxide is just O. Because if it ends in "ide," it comes from the periodic table, all right? Except for cyanide and hydroxide. Here we go, $1 million question. You ready? What is the charge of that iron? 3. Plus 3, but 3. You didn't even have to go look anywhere because the Roman numeral told you, and now nothing else changes about anything. What is the charge of oxygen? -2 from group 16. Can I cross those numbers as is? Yep, they cannot be reduced. So the 2 goes there and the twee goes there. This is iron 3 oxide. Does anybody know the common name of it? Rust. It's rust. Now it's easy, right? There was nothing new there. But hey, I don't want to hate you. You know how you can make me hate you? I mean, hate's a strong word, but here's how I could hate you. See how it says iron 3 oxide? You want to know what the dummy faces do? The dummy faces go, iron 3 oxide. Don't be that kid, please. All right? Because where does the 3 actually end up? On the other dude, not right there. Let's do another one. Here we go, still working together. The symbol for, here, actually, let's go talk to somebody. Let's go over to cluster 2. Seat 1, hey, 2-1. Can you tell me the symbol and charge of that nickel? Symbol and charge of that nickel. Quiet, please. I'm only talking to one person. Ni with a charge of 1. With a charge of +1. Everybody cool? Nitride is really just nitrogen ending in "ide" because he's bonded. What is nitrogen's oxidation state? -3 from group 15. Can I cross those numbers as is?
Yeah.
Yep, 1 and 3 cannot be reduced to any other smaller whole numbers. So the twee goes there, the 1 goes there. For a final formula, this is nickel 1 nitride. Nickel 1 nitride. It is, because I'm cool. All right, try both of those. You got 2 minutes for 2 problems. You got this. I'll show you.
Oh my God. Caroline, you're gonna stick that. Yes, you have four. Style something. Style negative. So this would be 1 and 2. Sorry. It's gonna be 2 and 1. I need help. So you can't write the bottom one. Oh, it's so it's down there. Okay, plus.
I just want to be able to read it all. But you can't.
What is yeah. Plus 2. Yeah. So oxalate. Oh my freaking Jesus, sir.
Don't call me that in front of everybody. It's a secret.
That was a good one.
All right, let's get some help on the first one. Lead 4 thiosulfate is how you say it. Let's go over to cluster 1 and talk to seat 2. Hey, 1, 2, just read me what to write for the answer. PB. Do y'all agree?
Yeah.
It's perfect. If you got something different, let's talk about why. It says lead 4, which means boom, 4. That's really easy. All right, thiosulfate, you just had to look them up, is -2, but you cannot cross as is, reduce them, chop them in half in this case. And if you do, that becomes 1 and that becomes 2. So the 1 crosses there, nothing. A number bigger than 1 crosses to a polyatomic, parentheses. Zinc oxalate. So you wrote zinc, and then you wrote oxalate, and then you might have thought to yourself, I need the charge of zinc. But remember, zinc, cadmium, and silver, those dudes right over there on that board on the bottom, are transition metals that don't use Roman numerals because they have a constant charge. Zinc is always +2. Oxalate is always -2. These will cancel to 1 and 1, and nothing will happen on the crisscross. Now, good news, bad news. Focus. The good news is that I have no other twists for you in regards to writing formulas. The bad news is that you need to be able to go both directions. Meaning we've only practiced writing formulas. What if I give you the formula? You need to be able to write the name. Now, Time for more good news. This is much easier. There's far less rules going this direction, which is why I'm able to knock out the reverse in the little bit of time that we have left. So refocus your attention and let's take a look. Write down that formula. That's the formula.
So why do you think it's called? I don't think I like it.
Don't say the F word.
Said font.
Did you say that one more time? He's saying font. I'm just kidding. Okay. Hey, look here. Now, I know it's ionic because rubidium is a metal and phosphorus is a non-metal, which is why we do what we're about to do. But here's the deal. All of our ionic names are made up of two words. There's a first word and a second word. So when you have a formula, you simply need to name the two parts. Like, don't draw this, but really, this thing breaks apart into two halves. They all will, and you just need to name each side. Now, if you're sitting there and you're like, well, what about the 3? The numbers don't really matter. The only time the subscripts matter going this direction is if they're polyatomic. It'll help you pinpoint the name from this list sometimes. But like in this case, it doesn't matter. Let me show you. How do you say RB? Rubidium. How do you say P, but when it's bonded? Phosphide, right? We end the second word in "ide" if it's from the periodic table. And that's it. You're done. There's nothing else to do.
Oh, so you don't have to write.
All right. Now, if you're worried about the 3, well, what happened to the 3? It's there, but it's hidden in the word phosphide. Phosphorus has an oxidation state of -3, but who cares? That part was done for us. If we have to go back to the formula, then we'd have to worry about that oxidation state. Let's do another one.
Oh, God.
Write it down.
CLO4 or the C10.
ClO4. C10. All right, look here. Now, in the first example, the numbers didn't matter. In this example, they matter a bit more because these are polyatomic ions. Now, those of y'all that took the time to memorize them, one of them at least should jump off the page. The reason the first one doesn't is it was in a section I didn't have you memorize. But look at the test-only section. Look at the test-only section. No, but look at the first half. See the NH4 in the test-only section? NH4 is pronounced ammonium. All right, so NH4 is ammonium on your polyatomic list. Now, one that you did memorize, and you're like, hey, I know that guy because I'm such a good student. What is ClO4? Perchlorate. And that's it. It's so easy to go this direction. You just name the first part and name the second part. Do not put your stuff away. Now, if there was a type of problem going this direction that is going to cause you issues, it would be this next one.
No, I said no cobalt.
All right, let's see if you can see the trick here. Give me your eyes. We're still together. We'll break up in just a second. Now, Fe is the first part, which is But here's what your brain needs to do. Look, look, look. If you're going this direction and you write down the name of a transition metal, y'all, you've got to tell other scientists the charge of that transition metal. If you try to identify this compound, but you don't tell someone else iron's charge, they will be lost. They'll have no idea which iron was in that compound. But you can tell them. So again, here's the red light, and I know this is a little abstract. But if you write down the name of a transition metal, you need to tell us its charge also. So, second gold star, what's the charge of this iron? It's 5. How do you know it's 5? Because the charge ends up on the other guy during the crisscross. So it's iron 5. How do you say the second part of that? Carbonate. I still got you for 7 minutes, man. Hey, you know what I bet y'all could do in 7 minutes? I bet you could be really impressive.
Oh my God.
Name them all. Come on, we got this. We got this. Name them all. I'll show you. Come. Do you want to talk to them? Do you want to say hi? But it can only be you, because I don't have permission from everybody else. Nope, that didn't go very well.
Hi.
All right. Anyways, there they are, the red examples. Get them named. Come on, prove to yourself you can do this. PT is platinum.
You didn't know. Obviously, you didn't know.
You can verify how you're doing with the shoulder, buddy. Come on, we got time. Get it done.
Fluoride. Or no, it's gallium fluoride. Right? But it's not bonded, right? Or is it bonded? So is the fluorine bonded?
Yeah, these are all compounds.
Oh, that's right. So it's fluoride.
Exactly.
Isn't fluoride?
It's the ions that are in your toothpaste.
So what is gallium fluoride?
It's very, very bad for you. But it's a type of salt. Keep working. Keep working. You don't have time for that.
Why are you making us ready?
Landon's bad for you, and I make you sit by him.
Well, then movie. If you were really looking out for me.
Sir, I am not a bad influence. I don't do drugs. Always. Where is I'm looking for it's not sale.
PT? It's playing time.
It's not. Found it. PT2, right?
Hey, don't hit on it.
Oh, it doesn't matter.
I know earlier I was like,
Oh no, yeah, it doesn't matter.
All right, I'm starting to run out of time, so I'm gonna push forward a little bit. You're welcome to keep working or watch me or whatever. Just be quiet. Here we go. GAF3. All right, that one's real easy. There's just two things. GA is pronounced gallium. F is pronounced, when bonded, fluoride. All right, let's go to the second one. The first thing I see is PT. That is platinum. But when I write down a transition metal, I have these sirens go off, unless it's cadmium, zinc, or silver, right? But I have these sirens go off that I need to tell you the charge of it. Platinum's charge here is what? 2. Because 2 is the subscript of the other dude. All right, and then ASO4 is pronounced arsenate from your polyatomic list. Example 3 starts with Mg, which is pronounced magnesium. Hey, do I need to add a Roman numeral for magnesium?
Yeah.
No. If you start going Roman numeral crazy, you're wrong, wrong, wrong. Magnesium's in group 2. That's not a transition metal. Only the transition metals can have Roman numerals. Magnesium's charge is always +2. Why would you show a Roman numeral? Magnesium permanganate. All right, hey, this last one's a trick. Look here, I know you're ready to leave, so am I, but look. RH is rhodium, in case you didn't know that. All right, but besides that, this one is the hardest type of problem. I don't do this to you very much, but let's see if you are smart. What is rhodium's Roman numeral? He's a transition metal. He needs a Roman numeral. What is it? It's not 2. Watch, 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 watch. You see how the other half of him is sulfide?
7.
Quiet. What is sulfur's charge always?
-2.
Sulfur's charge is always 2. It's always 2. But look, rhodium doesn't have a 2. It's got nothing. What is the only thing that would block sulfur from crossing this 2? What? The only thing that would block it is if something over here changed it. The answer is rhodium 4.
Yes.
Because only rhodium 4 would make these numbers reduce to a 2 and a 1, and then that 2 would show up. Very hard example, but it's chemistry and you are smart. Well, not you back there.
You say we're not